Great. So first, we're going to do some intro to metaprogramming, when and when not to use meta. Cannot really give a metaprogramming talk without that. Well, at least look down upon to do that. And then we'll get into metaprogramming Elixir and kind of pillars of metaprogramming Elixir, what allow Elixir to be, bootstrapped and stuff like that. And then we'll talk about usage testing with metaprogramming, again, a term that I think I made up. And we'll leave some time for Q&A and discussion. I think that's like my favorite part about Boston Elixir meetup. So I'll make sure I, leave some time for that later. So metaprogramming is, pretty basic code that writes code. It's also called generative programming because it generates logic or code. So generally, code that's considered as metaprogramming either generates code, analyzes other code, or injects behavior into other code, right? So essentially, we're saying for a metaprogram, code itself is an argument or data. So the code becomes a second-class citizen to the metaprogram. There are some languages, the language in which you do metaprogram is called meta language. And there are some languages whose meta language is themselves. So like Elixir is an example of that. And that feature is called reflectivity or reflexivity. I'm blanking on that term. I think it's either or. And yeah, like a lot of modern languages like Ruby also has that. And with reflectivity, you can think of metaprogramming as just a way to extend language functionality. And it's really cool to have that built into languages. It allows us to build Phoenix router DSL like this. Phoenix, for people who haven't done a lot of Elixir, is a web framework in Elixir. And the router DSL in Phoenix looks somewhat like this. And it's possible to write it in this way because of metaprogramming. So quick pros of metaprogramming, if done right, are it hides complexity, increases developer productivity, automates the tedious boilerplate code. Like here, it's, this kind of basically what it's defining is like a way to define a route that accepts JSON. And, it hides a lot of complexity, right? So and can make the code easier to digest. So it's easier to follow along this without worrying about what's going on in the background. Cons of metaprogramming, even if it's done right, are it increases complexity. And this kind of goes with what I was saying earlier. It's like it takes other code as its argument, which is why you're writing code that's higher order than your average code. So it's harder to do things with that code. It increases complexity. Decreases transparency, and this is like the trade-off you make. Because this code is easy to digest, it decreases transparency to what's going on. It's harder to test because it's harder to test. It's complex code, and similarly hard to maintain and debug. These three things are really a symptom of the fact that you're writing more complex code. So you should use metaprogramming only when you have used up all the other options. This is like straight from Chris McCord's book. When you can understand, can explain, and can document what you're doing. When you can minimize the meta code. And that really means that the code that kind of injects behavior or changes a behavior, that's called meta code, right? You can put the business logic of that behavior in a non-meta code and reference that in the meta code somehow to change the behavior. And we'll see an example of that hopefully today when we're going to do some live coding, by the way. So I'll hopefully cover some of these things. And on top of making fun of myself, because live coding is fun. Great. So and when you have maximized how deterministic the metaprogram code is by testing unit or integration, however, right? You've maximized its visibility. Also, you can use it when the requirements are less volatile. They don't change very often. It's kind of easier to maintain the code. And when the cost of failure is manageable, you always have to worry about that because, no code works 100%. So for example, I'd be a lot more comfortable writing metaprogramming for like a testing DSL than a production core code, right? So yeah, these are the things you should think about. It's not exhaustive. I just came up with this list a couple of weeks ago. So yeah, if anyone wants to add something to it, we can talk more about this. But metaprogramming is not evil when used thoughtfully, and it exists for a reason. So when you have thought about all those things well, and you come to a conclusion that you should use metaprogramming, then go ahead, because it exists for a reason. Great. Let's talk about pillars of metaprogramming in Elixir. So like I mentioned earlier, Elixir's meta language is Elixir, which means Elixir, you can change Elixir code writing Elixir. And Elixir does that. And this is just like an FYI. It's not part of this talk. It's just Elixir does that in like a lot of layers. This is just going to cover how to use the meta language Elixir, but how does the meta language itself work? This does not cover that. So there's like a lot more beyond this talk in how Elixir works under the hood. But this talk is just going to be focused on what we think of as metaprogramming when we do Elixir. But there's a lot more to it. I just want people to know that. All right, let's get to it. So in Elixir, there's 3 main constructs for metaprogramming. The AST, abstract syntax tree, and its Elixir representation using quote and unquote. The AST, for people who don't know, it's the representation of code and the tokens of the code that you get after the syntactic and lexical analysis of code. So like parsing and tokenization produce AST, and Elixir has an Elixir representation of AST. It sounds a little meta, but it is supposed to, right? And then we'll talk about code injection using macros. This is where you change behavior of other code. So now that you have AST, how to manipulate the AST. And third would be compile time hooks, like how you can hook into compilation of a module, and based on different parameters, make things happen. So, all right, ASTs and Elixir. So in Elixir, the Elixir representation of AST is called quoted expressions or quoted literals. And to get an AST representation of code, you can use the quote macro. Well, ignore the fact that I said macro because we haven't covered macro. Quote keyword, how about that? So you can use quote to get the AST representation of an Elixir code. So let's do this. Great. So let's say we have this code 1 + 2, right? 3. If we want to get the Elixir representation of its AST or quoted literal, we can do quote 2, 1 + 2. So it returns a 3-element tuple, which is like the Elixir representation of its AST. And let's see what that looks like. So it's a 3-element tuple, right? The first element is always an atom. Well, let's focus on it. Yeah, it can be a tuple, but let's focus on the atom part. And it represents the function that's being called. So here we're calling the function plus, right? So the first element is a function. Second element is the metadata that kind of shows the environment in which this a block is being quoted. So here it is, like the modules that have been imported, kernel, it's imported by default and whatnot, right? Again, let's not pay too much attention to that right now. And third is the list of arguments that are passed to a function. So to plus, we're passing 1 and 2. So this is the Elixir representation of the AST. Real quick, it doesn't look like a tree, right? So I spent an embarrassing amount of time writing this the other day, which prints a quoted literal, I hope. In a tree format. So this more looks like a tree. It kind of uses that directory tree like syntax. So yeah, this is these are quoted expressions. So now the quoted expressions can be evaluated with code.eval quoted. So we can do code.eval quoted, and evaluate a quoted expression. And it returns 3, and also any variable bindings that might be present in that context. So yeah, that's how you evaluate a quoted expression. Right. Cool. Let's see. Oh, right. Before I get there, there's one more thing I wanted to cover. So I just want to really emphasize the fact that this is just a 3-element tuple is how Elixir interprets code. So let's do this, right? So let's do quote do 1 plus a, right? And if I do code.eval quoted, well, let's assign that to an expression. I'll call it expression equals that. And I'll do code.eval quoted expression. Can anyone guess what will happen when I hit enter?
Integer plus atom? Oh, no, sorry. Is A an atom?
A is not an atom. A is a variable.
Gotcha.
But yeah, any guesses? What will happen? Did we define A anywhere? No. Right. So it says variable A doesn't exist. So right, undefined function A, it tries to interpret it as a function. So yeah, I mean, that doesn't exist. So we have this expression which tries to add 1 with A. So let's define an expression 2 where we define A equals 2, right? Now let's write an AST and add expression 1 and expression 2 goes before expression 1 because expression 2 defines A. And give that as, so we're going to define a block with those two as arguments, right? So we're going to combine those two quoted expressions into a block, and let's call it exp. Great. And now let's do code eval quoted. Great. So this time it returned 3 and returned what was defined. So I did this just to emphasize that it's literally just 3-element tuples. If you can play around with them and change code just with these things, you don't need macros. Just wanted to emphasize that. All right, so let's get to hygienic evaluation. Great. So another thing is if I define expression was 1 plus A, right? So also if you're not sure what this means, you can always do macro dot, oh man, what was it? ToString, right? So it prints a quoted expression as a string. So expression kind of corresponds to 1 plus A. So if we define A here, and then we did code eval quoted expression, it will not work. So you cannot. That's called like hygiene for a quoted expression. You can evaluate a quoted expression only in its context. So you have to explicitly pass the variable bindings to evaluate a quoted expression, and that's one of the things I like about Elixir metaprogramming, that it's so restrictive to prevent weird things from happening. So to evaluate this, you can do A equals 1, and the second variable to second argument to eval quoted are the bindings. Oh, right. I'm sorry. You also have to refer to that as 1 plus var A, otherwise it won't work. So you're explicitly saying that it's a variable you're going to get from the evaluation context. So now if you do this, you can evaluate that. So that's the var macro, which allows you to, pass a context, pass variable bindings, and evaluate a quoted expression more dynamically. So that's var. Any questions about var? Or rather, I should be asking, does it make sense? Can I get one yes?
Yes.
Yes.
Great.
Yes.
Awesome. Great. So yeah, so var is a way to evaluate a coded expression by giving a binding, by passing a binding. Now, what if you want to evaluate a coded expression when you define it? For that, we have unquote. So we have variable a defined, that's 1, right? I'm going to clear the screen. So I'll just do a equals 2 for a change. And now I want to define expression as quote do 1 plus a, what is defined at the time of definition of this quote. That's where you use unquote. So it evaluates that right away as 2 instead of a. So it's an important different thing you should remember. Unquote, you should use that when you want to add dynamic behavior to an expression at the time of its definition. And var is something you should use that when you want to add dynamic behavior at the time of its execution or evaluation. Cool. So macros, short for macro instruction. And yeah, macro is a way to inject code, change and manipulate an AST instead of like manually adding 2 coded blocks like I did. Macro is a way to do that in a more programmatic way. There is a bad way of doing that, and I'm going to show you that. So let's I'm going to call it code eval. Great. So let's define a function, a module, behavior, injector, and let's define a function called behavior, not you. And what this does is, so location keep real quick is if you pass location keep to quote, it helps you with stack trace. You know what? I'm not going to use it. Why use it? Cool. So let's say this behavior defines a function hello, which prints hello, right? And now let's define a module test subject. That sounds bad, but whatever. And we want to use these coded expressions here. So we can do code.eval quoted behavior injector dot behavior, right? We're evaluating that, and we're not passing any bindings. The third argument for eval quoted is the environment in which you have to evaluate it. That's a required thing to evaluate a quoted expression. So yeah, let's go to IEX and see what this does. Let's compile code eval and test subject dot hello prints hello. Great. So this is, we injected behavior, right? This is metaprogramming. Now, does anyone see any problems with this?
Well, you didn't actually need metaprogramming.
That's true. Besides that, that's a very good point. But like just using code eval quoted here, any places where things can go wrong?
You have injected that into any module by passing it in the end.
Right. That's right. That's so correct. Exactly. So the code.eval quoted allows us to pass whatever end we want. So if any module is not compiled, we can pass its environment and compile that module. And same goes for bindings. We can do whatever we want in a really weird way. So that's why this is called a bad way. That's why I call this a bad way of injecting behavior. The right way of injecting behavior is by using macros. So let's change this to macros. So instead of a function, This will be a macro. We define a macro with def macro, which is a macro itself. And instead of doing code eval, we just require the module in which the macro is defined and just call the macro. And you know what? I'm going to change the string just to make sure. I'll make it world. Just, so it prints a different thing here. But okay, test.hello prints world. So like I'm not sure who said that, who answered the previous question, but we had a lot of flexibility. We could send any environment, right? Here we cannot. Macros are always evaluated or expanded is the word in the context of the module or the current context. And that's why they are the better way of injecting code. We actually use so many macros in Elixir without even knowing. If is a macro, with is a macro, def module, and def macro. These are all macros, which is pretty awesome. And this is where I was when I was explaining that below the Elixir meta language is another language, another layer that Elixir uses to make things work. Oh, also, there's also a special macro called using with one arity. Elixir likes that. I don't know why it's a special one, but it is. So if your macro is __ using __ with one arity, you can, instead of doing both of these things, just replace that with use behavior injector. And yeah, it works. So let's switch this back to, let's call it hello world. And hello world. So yeah, it's a special macro, using macro. Don't really know why. I think the intention is, if you're using macro, if you're injecting behavior from one module to another, use the using macro. Let's go to compile time hooks then. So yeah, they're also called compile time callbacks. And there's like 3 types of callbacks. There's a before compile callback, which is invoked before a module bytecode is generated. And it takes one argument, the environment. So let's take a look at an example. What can we do for, oh yeah, let's do this. Let's keep those. And instead of use, let's call this before compile. So this defines a before compile hook. And by default, it looks for a function or a module with the name before compile in the module that you have passed to as before compile. So this should exactly behave the same. Code eval, and let's print. Great, byworld. So yeah, it changed the code. So yeah, that's before compile. Yeah, and as you can see, it has to be put in a different module because this module hasn't done compiling. And after compile, it is invoked after the module's bytecode is generated. It takes 2 arguments, environment and the bytecode. And this function actually can be put in the same module. So you can put oh, also this __ module _ in Elixir means the current module. So this is same as like me putting test subject there. So after compile, okay, let's, so now as I compile it, it should print compiled test subject. Great. So that's after compile. And let's see. The third one is on definition, and that's invoked whenever a function or a macro is defined in the current module. I've heard stories that this hook was added for Phoenix because Phoenix was such an ambitious project. So I don't know if it's true or not. That's what I've heard. On definition takes 6 arguments. I'm not gonna read through those. Yeah, takes a bunch of arguments, and it only allows functions, no macros, and that's again to restrict the developers to do something weird, because a function is already being defined, and it would just be too powerful if we could define macros. Let's take a look at on definition, and that needs to be put in a different module too, because the module hasn't done compiling. And on definition takes 6 arguments, 4, 5, 6. Let's see, let's use a few of those. Let's name and body, maybe. Name is third and body is last. Defining a function named name with body. Great. So this should print every time we define a function, it should print this. So now let's see what's happening. Before compile, we'll define a function hello. So it should print, it should hook into on definition hook. Let's make sure this is before. I don't know what will happen if it's after. I don't actually, you know what? It should be, it should still work. It should still work. And it should also print after compiles body. So we're defining 2 functions, hello through before compile hook and the after compile function. So let's clear it and recompile this. Oh, compilation failed. Shoot. Oh, this might be a code expression. So we might want to do macro.toString. Great. So defining a function named after compile with body puts, and defining a function named hello with body by world. Great. Okay. Quick question. Can anyone guess why it prints after compile message before the hello message? That means after compile function is defined before hello, even though before compile hook is here. Any theories, guesses? Did people understand the question? I can repeat it. Does someone not know why?
I understand the question.
Okay. Okay. Cool. Well, I can explain. So it's kind of I think it's just showing what before compile does. Before compile is called after the entire file has been interpreted. So after compile, even though it's like written after in terms of lines from before compile hook is registered here, but it's not called until the last line of the module is defined. So this will always be inserted at the very end. And that's a very key thing to know right now, because we're going to use that fact later to do some usage testing. But was my answer clear? Sorry, guys. It's like I don't have like an audience in front of me. Okay.
I understood. I think it was clear.
Great, awesome. Yeah, I keep asking because I don't have like people in front of me, so I don't know how people are reacting to what I'm saying. So sorry for my need for whatever. But yeah, cool. So that's on definition. We'll see examples of that. It also has to be in a different module. Great. Okay, and callbacks are defined in the order of in the order. So if you have 2 before compile callbacks, they'll be executed in that order. Awesome.
I have a question, Adi.
Yeah.
So I noticed that these compilation hooks
Mhm.
are eventually invoking, in two cases, expressions, I guess functions, and in another case, a macro definition. Is there anything that you could say about that, or do you like? I know you said that on definition can't invoke macros, right?
Right.
For just macro expressions. So
Right.
yeah.
Right. So I think that's the only rule. After compile and before compile can be functions or macros. With after compile being a macro, there isn't much you'll gain out of it because the modules bytecode is already generated. So if I let's try it. Actually, I have not tried this yet. So I'm glad you asked that question, RJ. So world. Let's move this up. Yeah, let's see what happens. Oh, wow. Okay. Very interesting. So defined, great. So you after compile can still be a macro and you can still add code to the current module, even though its bytecode has been generated. So that's interesting. I didn't expect that. I thought we would get an error that saying that the module has already been compiled, but yeah, so it defined world. And another cool thing is it defined hello before world. Because this macro it waited to evaluate the macro after the before compile hook. But yeah, great question, Ajay.
Cool, thanks.
Cool. And any other thoughts or questions? Okay. All right, so let's get to this, right? Usage testing. And I'm quite nervous talking about this because I had this idea has been like sitting in my head, and I made like a proposal on the Elixir groups, and Jose kind of shut that off right away. And like I tried convincing him, and he said that he doesn't like this style of testing. So let's get to it. I just wanted to kind of set the platform for people to already not be on board with this, So, I mean, it's really testing how a dependency is used rather than what the dependency does with their code. So how you're using something rather than the integration of your usage. Or another way of saying it is like, if you've sufficiently tested the dependency, then it's not a crime to focus on testing just its usage rather than the entire integration. There are a couple examples of that, like, and this is like for Ruby on Rails people, like shoulda matchers. Does anyone know how shoulda matches would work? Like, if people don't remember what shoulda matches are, you can in Rails, if you are, say, a model user, right, validates presence of email, right, and in your test you can write something like expect this to validate presence of email, right? Instead of like creating a user without email and saying if it's valid or not, right? Instead of like doing the entire thing. My question is, does anyone know how shoulda matches work? Do they actually do the entire thing, or do they do something else? Does anyone have any ideas? I know the answer, but I'm just curious what people think what shoulda matches do. Okay, well, if no one has any thoughts, so what they do basically, instead of doing the entire integration, they check what your class is configured to do, right? They basically essentially test, does the model validate the presence of email, like by calling validate presence of email, instead of creating a like an instance of the model without the email and checking whether it's valid or not, right? So what shoulda matches are doing is usage testing, right? It assumes that active record, which is part of Rails, works the way it works. I believe it. Now I just need to check whether we're using it correctly, right? Does a high level idea of this make sense? I'm going to show more code, but I just want to make sure the philosophy of this, if it makes sense to people, or if someone is completely opposed to it, or if anyone has any thoughts on that before we get to more examples.
I think shoulda matchers. I think the only exception might be the validates uniqueness of
right
constraint.
right
So, just to throw that out there, I think like I ran into this at one point, and that's the only reason I remember it.
Right. Uniqueness is weird because you do need the data, but it still does that without trying to insert, right? So it just gets the other corresponding data to it and then checks if it's unique, but it still doesn't do like model.new with a non-unique field .valid, right? It doesn't do that, if that makes sense, Josh. No.
I think that makes sense. I thought it did, but
Oh.
that makes sense.
Well, you know, I looked at shoulda matches a while ago, so maybe it has changed. I looked at it like 2 years ago, but I don't know.
Sorry, this is not a Ruby talk. My bad.
Yeah, no, that's totally fine. It's my bad. I brought up as an example. And really, part of the reason why I brought up shoulda matches is because there isn't an Elixir equivalent that is being used by everyone. I want to write an ecto equivalent. I have written an ecto equivalent of that, which is private, because I'm like ashamed to make it public because people just don't like this way of testing in Elixir. And I'm just trying to, hopefully either change my mind or change people's mind. And I'm using this meetup as a medium to do that. But anyway, anyone has any other thoughts before we get into examples? Did everyone understand the philosophy of this? Yeah, go ahead.
Yeah, I think I do.
Awesome. Thank you. Great. So use cases. Now this one, I don't know. I've not done this code, so I'm gonna just literally do this live. But this one is like a simple example of using. So let's okay. So let's define a macro using with options this time. And let's say you can pass an option greeting. So options is a keyword list. So you can get keyword dot get, and let's say it defaults to hello, and ops default to an empty keyword list. And you can, what this does is it defines a function greet, and we're going to use unquote. It does that. Great. All right. That's good. So that's the behavior injector, and we're going to use behavior injector here. We can also define another one, test subject 2. I'll just make this 1 because I'm weird. Okay, so cool. So so we have, at a high level, this behavior injector defines a function greet, which just greets based on the greeting that we pass to this module. If we pass no greeting, it says hello. If we pass a greeting, it replaces it with the greeting that we passed. So my thinking here is, say if we write the tests for this, right? We're gonna change this to well, nah, I don't know. Okay, yeah, let's do xunit start. So xunit is the testing framework, unit testing framework for Elixir. And let's write test subject 1 test, and let's assume this is tested, right? Let's assume this is tested. Sufficiently tested. Okay, great. So So I'll say describe using for this, right? So how we will write this would be like, how would we test whether it's being used correctly? Is we will defines a function greeting which prints hello. Let's actually replace print with just return. I don't want to capture IO to test. So great. So we can do assert test subject one dot greeting equals hello, right? And write another test for test subject 2. And print hola. Great. So let's compile this file again. And let's run the test. If for people who have not done this yet, does anyone know how to run a test from the console for a file? I do, but I'm just curious if people, anyone else does. It's actually really, really weird. If no, then I will show it off then. Okay, so you run, you put the module name, the test module name, and then there's a function, which is literally the name of the describe block. Or not describe, the test block with test in front of it and as an atom. And you can pass it one argument, which is a context, but it's empty this time. So I think that's what it is. No. Oh, you know what? I put, I'll not put that. I think it's complicating things. Let's recompile this.
Try it with a empty list, maybe.
Empty list. I think I might have these ticks. Maybe that's why.
Oh.
No. Oh. Test. Oh, I forgot using the part of describe. Yeah, because it also adds describe, whatever you're describing, to that. So it's unique. Still not that. Okay. Did you mean this? I'm gonna copy that. Did you mean? Okay.
Hello versus hola.
Oh, right. Thank you. Yeah, we're using a different module. Thank you. Great. Oh, greet is not defined. Woo! What happened?
The method's name is greet, not greeting.
Oh, right. You're right. Thank you. Man, I should have thought before designing the live code. Cool. All right, cool. Okay. Sorry, someone was saying something?
I was going to say braver than me.
Yeah, that's actually one reason to do live coding, because people are so empathetic, right? If you do actual mistakes, you can get away with it because people say, oh, at least he was live coding. It's okay. So yeah, it's actually a trick. Cool. So yeah, that test pass. And let's run test subject 2 test and great. So that works too. So now what we're doing here is we are really testing behavior injector, right? What it does with different cases. Because if we have tested that sufficiently, we know that it defines a function greet based on whatever greeting you pass. So what I want to do is, instead of this, do test uses behavior injector properly, whatever properly means, right? So essentially something like get uses from test subject 1.uses, right? And do assert behavior injector with empty, like no arguments in uses. So, right, and similarly here, test subject 2 with greeting, hola, right? So that's what I want to do. So let's try to make this happen. We would have to define a use macro. So let's define a module introspectable kernel, because kernel is where users define, rather kernel special forms. So let's define introspectable kernel and call this use, and we pass in a module and options, which default to an empty list. And okay, what does use do, right? It basically requires the module and calls using with options, right? That's what use does. So let's make sure that we got the basics right. So I'm going to replace this with introspectable kernel.use. Oh, there's a weird way of doing that too. We can do import kernel only nothing and import introspectable kernel. This is a bad way of doing that, but let's do the bad way for now. So let's recompile this and see if this still works. It still works. Okay, so that's basically what use does. It might be a little bit more than that. It is a little bit more than that, but at a high level, this is what use does. Right, requires the module and calls using macro, right? Now, what we want to do is we want to store the information that we are using behavior injector. So let's put in a module attribute. So you can do module.register attribute, and you can call register attribute even if the attribute is already registered. It will not fail. And let's call it uses, and let's say it's accumulate true. So in that way, every time you call it, it adds to that accumulator. So after calling use, let's do uses and unquote ops. So now every time we call use or use macro, it will store that in the module's uses attribute. So yeah, so we can at the end define oh, we could also do this. We could do before compile introspectable kernel and define a macro before compile, which defines the function that we're using in our tests. So I think, well, what do we call it? We call it uses. So we can do def uses. So we know that before compile gets called at the very end. So no matter how many times we call the use, it'll always be called at the very end of the file. So uses will always have the latest state of the module attribute uses. So let's run this spec, right? Let's recompile this file. Okay, actually, let's make sure it fails, right? So let's do refute. It just returns okay. I don't like how it looks. Okay, great. So it did find it behavior injector with options in uses. So yeah, now that we know it works, we can just update that again. Cool. So I prefer this test over testing the behavior of the behavior injector over and over and over again. So again, this goes in with an assumption. Once you have already tested the behavior of the dependency, which is the behavior injector in this case, sufficiently, you should be able to do this. Okay, I want to get thoughts on this because this was rejected. This proposal was rejected from Elixir. Any thoughts?
I like it.
Oh. Nice. Thanks, Josh.
Pretty bummed out, but yeah. I have like I guess like a small question. Just because I haven't done a lot of metaprogramming. Is there a reason why you used the module? If you scroll up a little bit on your the register attribute, why you used the module like underscore instead of mod?
Right. So this is yeah, I could use so we want to register the attribute to the module that is being compiled, right? And mod here is the module that's being used, right? So here.
Oh, you're right.
Yeah.
I got it. All right. Sorry.
Yeah, no problem. Yeah, I might have, I'm glad you asked that question, Josh. And people can feel free to ask questions, and I sometimes tend to code fast, and it's okay to kind of stop me and like just ask me to explain something. I really would prefer that, and a lot of times it makes me look at things in a different way too. So if any of this did not make sense, please let me know, and I'd be happy to explain. Okay, any thoughts on this? Like, does anyone else besides Josh like it or hate it or are indifferent?
I have a question on it.
Yeah.
So the test that you want to do is accessing like a history of the macros that got executed in that module. Just uses.
Right, exactly. Yep. So whenever you call use, I just want a paper trail of that.
Okay. And that would not be equivalent to like reading the file, like not the compiled version, but the original version to check if it uses some behavior.
What do you mean by
so like in this test, you're checking that uses attribute.
Right.
And if you did like read file on that actual file and then did like a check for uses some behavior.
Gotcha.
Why would that be different for your like test use case?
Right. I mean, it in this case will not be different, but it's just the complexity of code here. You'll have to write a parser for it, right? Like comma, this goes into options and stuff, right? If you start passing like code expressions as options and stuff, you'll have to write parser for that. I just feel like why read it as a raw string when you can store that information programmatically, right? Does that make sense?
Yeah, it makes sense. Like I get it for the testing part, but like would the runtime ever use those things?
Use these things? Not really. I don't think so. Well, so this is another place, man. One of the things I mentioned, right, that metaprogramming, I think, kind of visibility is a catalyst for sustainable metaprogramming, and this adds visibility, right? And one of the things I also feel like when we working at a couple places in the past without naming the companies, that it's the incentive to write tests for these, for all the cases for this behavior injector, is like so less. People often don't do that. And this, by keeping this interface simple, also incentivizes people to write tests. And it sounds silly, right? Because people should always write tests. But if this behavior injector gets more complicated, you have to write all those tests as part of the test subject tests, right? But if you can just test the usage, it's still one test. And there's more incentive to write that one test than X number of use cases. And I think that influences how you write code. So it's not really something you need in production environment, right? But it really influences how deterministic your code is, if that makes sense.
Yeah, gotcha. That makes sense.
Yeah, it all really stemmed from that. Really, I felt like people, and even with the code review process and stuff, as things get more complicated and the more number of use cases people have to test again and again, the tedious, it almost becomes boilerplate at that time, at that point, right? So, but those tests should exist, but because without them, how would you know something is broken, right? And that was the kind of motivation for me to add a couple of examples of this in the code bases. But I actually thought that Jose will be excited about this. And it's a bummer that currently it's a no. But yeah.
So I guess after looking at this for a second, sorry, I think one thing that might make it better from my standpoint would be to have that uses variable not be on the module itself, like the module attribute, but to maybe like register it somewhere else so you're not polluting the module.
I mean, the module, we're not persisting it. So we're not persisting it. So it's not really, it's only there at compile time. So if you do like persist true, then it'll pollute the module, right? But which is why I'm defining this function here.
Oh, I just saw them. Okay.
Right.
My bad.
No,
but all right, that makes sense.
That's a great point. That's a great point. But yeah, if I were doing persist, that's the reason why I'm not doing persist. It's also the way module attributes are persisted. It's like so weird. I try to use a function instead of a persisted module attribute whenever I can, because I just don't trust. So how the module attribute is defined is in Elixir is in an ETS table that's namespaced for the module. And once, if you persist it, it keeps the ETS table. And after compiling the module, it adds that information, the compiled time information to the module. And I don't like that. I'll just stick to my functions. So, but yeah, it was a fair point, Josh. Like if we should, I would not persist the module attribute.